Hello everyone and welcome back to another Universe Sandbox video, and today we're going to be evolving the solar system itself to death. So this is kind of like a solar system version of the evolving from birth to death series, so I thought I'm going to try it with the solar system. We're going to make it really in depth, because I did cover this sort of before, but we didn't really go in depth with like every single stage of the sun getting bigger and watching all the planets as they slowly change over time and stuff. So we're going to do this properly like we would in our birth to death series. So without further ado, guys, let's get cracking. So solar system, present day, that's everything we've got. So all the way down here, as we can see, what I'm going to do is we're going to focus on the 4 inner planets mainly, because that's probably where we're going to be looking, because this will probably take 2 or 3 episodes to get through. So I'm going to do this to Mercury, Venus, Earth and Mars. So we're going to have all of their surface temperatures up here, and we're going to slowly watch as they change. So Venus, same principle with you. So we don't need the surface maps actually. So yeah, we've got Mercury, Venus, then Earth. I guess we could probably have some more features for Earth actually. So we're going to do that with you. So there's Earth currently. So there you go, water vapor, water depth. So yeah, we'll keep an eye on all of that. We'll keep an eye on all of those. And then lastly we have Mars down here. Actually, no, what I'll do is I'll have Mars before the Earth ones, just so we don't have all of Earth's bits in the way. So there we go. So then Mars, press this, and then get rid of all of those. Excellent, like that. So Mercury, Venus, Mars, and lastly we'll have Earth at the bottom with all of its bits here. So looking good. We don't need the elevation though. Right. So we don't need that either. So looking good. So now we have that. Close this. Right, so the sun itself. So this is the sun in the present day. So you can see Mercury, Venus, Earth, Mars are all just doing their normal thing currently. So there you go. So slowly watch as things sort of move around. Just, you know, normal present day stuff basically. And obviously we've got all of the asteroid belt objects in there. All of the major sort of dwarf planets are out here as well. I've got a few less ones. Like we don't really need this, for instance, or this one, so we'll get rid of those. But yeah, all of the names we know, so like Hermea, Make, Sedna, obviously Iris. Like we've got all of the well-known ones. So apart from this one, what's that in there? Get rid of that. Right, and then also we've got some of the asteroid belt objects as well in there. But anyways, the sun. Let's actually start to evolve. So what I'm going to do is I'm also going to save, because I don't know how unstable this will get if we start messing with the sun, because sometimes the sun can be a bit buggy. So we're going to call it SS for solar system. So we'll just call it B to D, even though we're not doing the birth side of things. We're just evolving from the present day to the end. So okay, the sun. So over time, obviously, the sun's going to get larger, radius, and slightly brighter. So we're going to start to do that and evolve into the future a bit. So just tiny little adjustments. The sun's just getting a bit bigger. So we're going to go to 0 or 1.05 luminosity of sun. So the zone's going to get a little bigger. So slowly watch as the Earth's temperature is increasing. So it's going to the 30s now. So yeah, we're slowly going to see Earth's average slowly increase higher and higher as time goes on here. So this could get pretty dangerous pretty quickly. So here it is. Here's Earth currently. So remember, this is a custom variant. So that's why it looks a little different. It's got more clouds added to it basically. So there it is. Okay. So we'll keep an eye on those, and also keep an eye on like Venus, Mercury, because we're going to slowly see their temperatures slowly creep up as well. So again, we'll just let time evolve. So we're going to just run the simulation at high speed, slowly watch as things slightly change. And just look at how everything moves around an orbit anyway. Look how things just slightly go up and down, just depending on where the planet is in its orbit. Obviously, Earth's tilted, so as it goes around the sun, you get the north or the winter and summer effectively. So that does slightly go up and down a bit. Pretty cool stuff. Same principle with Mars, tilted on its side. Venus and Mercury are more sort of straight, so they don't really have seasons as much. But yeah, Mars and Earth, they're tilted, so they do have some sort of season sort of thing going on there. Okay, but look, already, so we've evolved the sun just a tiny bit, and Venus is already into the 500s at its hottest points. So yeah, Venus, pretty hot stuff under there. So yeah, definitely would not want to be there right now, because that's just going to get worse and worse from this point forward. So anyways, the sun. Again, we're going to keep evolving. So just keep an eye on that habitable zone as we slowly go up here. So again, it's going to get a little bigger. Just a tad. And then obviously luminosity is going to slowly go to 1.1 suns. So again, another increase. We can see Venus is now into the 520s almost. Earth, 37 degrees. Now that's just going from 1.0 to 1.1 luminosity of sun. So that's an extra 10% of what it is now. And it's already 37 degrees. So Earth is starting to get pretty hot. And I'd say by this time in the future, Earth's continents probably would have changed. So we're just going to have a little resurface of Earth. For instance, that. So Earth's continents have changed. Therefore, it will appear different. That's not exactly what I had in mind. Why is it looking like that? I made it a gas giant. What? Well, I guess that's an apocalyptic-looking future Earth. I mean, that's not exactly what I had in mind. Can we resurface, please? Oh, no, I want to change the surface texture. Come on, it can't be that hard, game. All I want to do is change the surface texture. Can we not do that anymore? What is that all about? Well, there we go. We've got our future sort of esque looking Earth. I guess. Oh, what? So you can't change the surface texture by making it a gas giant anymore. Aha! And that's completely ruined our Earth. Great. Yeah, we're just going to replace that with Earth again. I guess we can't have continental changes, which is a bit weird. That's a bit disappointing, honestly. I thought we'd be able to check. Maybe if I do it with a normal Earth. No, it doesn't let you. Look. Interesting. That's a bit annoying, actually, because I want to have a custom. I want to have a custom sort of surface texture for the future Earth with continental drift and stuff. So what if I just manually I guess I can amend it. So there we go. So Earth, and then also we just need to add the water back manually, which is a bit annoying. So we have upset its composition a bit, but I mean, I just want a custom looking Earth. So there we go. Radius, put it to 1 Earth. Or 1 it's because we've played with this a bit. That's why. Look, silica or iron or. So we have slightly upset the size of the Earth. Oh no! Look, if we make it bigger, it upsets the radius. Oh, that's so annoying. It can never be easy. Just one. I just want 1 and 1. There you go. Okay. Now, add me some water. Come on. I just want water. Come on. There you go. There we go. I just want a custom continental drift looking Earth. I don't want it looking like the present day. We're evolving into the future here. We need a custom sort of future landmass change. So Earth is now looking different with the continents all broken up and changed. So I guess that's the closest we're going to get, unfortunately, because Earth doesn't really want to cooperate with us. So yeah, we've got the futuresque Earth here, but the continents have all switched around a bit. So I guess we'll roll with that. And surface, I guess we'll give it a custom sort of. Yeah, it's still going to look pretty nice at this point. You know, it's not going to be completely scorched and stuff yet. So there we go. So we've got future Earth. There you go. Obviously, we'll pull it back to the. I always have Earth with the double sort of thick clouds. So there you go, something like that. So Earth, nice solar clouds at Earth. Looking good. 1 mass, 1 radius. There you go. I may have upset the iron a bit, but okay, could be worse. Can I unlock the padlock? Well, I guess. There we go. Okay, I'd keep the density the same. Everything else is back to 1 Earth. Okay, so there's a future Earth. And also you can see the constants, all the city lights are a little different now, but there you go. So that is a future design of Earth with the constants have all changed. Because obviously we're going into the future, so we need to try and take that into account that Earth is not going to look the same as it once did in the present day. So there we go. So forget me fiddling around with it. Just imagine that naturally changed. So there we go. Let's go ahead and save. Voila. Okay, cool. So we've got past the Earth being a bit of a tricky one. There we go. So Earth is now a future constant appearance. So looking good. So there you go. And obviously keep an eye on Earth's temperature as well. It's going to go up into the 30s. So let's just let that change. So it's 31.8 degrees right now, Earth. So yeah, not looking the best as it used to. So remember, it's got 1 ATM atmosphere mass of Earth. Okay. So average temperature, that's going to slowly increase here. Okay. So the highest points of Earth, they can go up into the high 30s. So he's kind of got like a super continent, as you can see, like with this whiter area, that big load of land there. So I guess you could kind of say that's a super continent. I mean, it's pretty cool. So let's just have a look at Earth without the atmosphere and clouds on. So yeah, you can see the lands obviously all changed. Okay. Okay, but I'll leave it alone. Right, enough of Earth. Right. Time evolve. And then the sun again. Again. Slowly but surely. Just slightly higher increase. The luminosity is going to 1.15s now. So look, you can see Earth is almost going into the 40-degree mark. There's the water vapor. Liquid water depth as well. That will obviously start changing. The ice thickness. You can see it. That will probably start to change with time as well. Venus, 520 almost now. Mercury, obviously that's going to slowly change as well. Mars is still not getting what it needs yet. So we're going to, again, sun is slowly going to increase higher and higher. So you can see Earth is right on the edge of the habitable zone now. So it's now going to go into the red area as we slowly increase luminosity of sun. So 1.13 suns, and obviously the radius will get a little bigger as well with time. So there you go, and the surface temperature will start to cool down on the sun as well. Okay, right. So to Earth again. Earth's obviously going to be the main sort of look here now. So look, if we got Earth, 50 degrees average temperature. So Earth, yeah, not looking too good now. So look at that average temperature, 22 degrees. Obviously, we're probably going to start seeing the ice decrease with time in the yeah, with time we're going to see the ice slowly melt and sort of vaporize completely. So obviously can't have ice when your average temperature's that high, really. I mean, look, the coldest points of Earth. So we still got anything in the... Okay, no, so it's still in the minuses. Okay. So Earth hasn't fully... It's not a fully crazy yet. There's still some fairly decent areas, but obviously you do not want to be on the equator, because that is at 50 odd degrees. So that is going to be some scorching sunlight from our aged sun, effectively here. So yeah, the Earth looking good. So obviously at this point, humanity are probably still going. You know, Earth probably still will be hopefully usable in some capacity, but obviously it's not going to last for much longer, unfortunately, with Earth. So we can see we're probably going to start seeing less grassland. So maybe the green starts to sort of fade out a bit. Maybe it starts to go more of a burnt sort of shade. So it starts going more to a yellowy sort of look, just slowly underneath there. So yeah, and also CO2 levels. Maybe the atmosphere will start to get a little more polluted looking in a way. So we'll get a little brighter there, and then obviously clouds. Maybe some more polluted looking clouds. You know, that dirty sort of appearance to it. So nothing too extreme, but just a slight change to the clouds in appearance. Whenever this is all speculative, we're just having a bit of fun here as well, but we do want to try and keep it a bit sciencey and try and go for a sort of realistic sort of design to it. So maybe yeah, just higher CO2. Earth obviously going to slowly start to get a little more toxic in a way, effective all that CO2 pollution, and also just general greenhouse effect from the sun. That's obviously the biggest player here is the sun. More than anything, forget humanity's interactions with Earth. The sun, that higher greenhouse effect with Earth, you know, the sun's gonna hurt it a bit. So you can see at Earth already, just that small little effect we did to its appearance is just making it slightly less appealing to look at in a way. So not looking good. And look at its stats as well. I'm sure they'll be dropping. So no, but Earth is normally like 100% on both of these. So we can see Earth has slightly changed. With that, also it's because we had to make it a gas giant to change its surface texture, you know, which is also very annoying. But oh well, we have to just live with it. So there we go. Is it me, or does the water look like it's gone down in a way in some areas? Let's have a look underneath. So that's what it looks like underneath. Okay. I don't know, but yeah, there it is. Earth. Cool. So 44 degrees average currently. Venus, how are you doing over here? So yeah, Venus would be just seriously, yeah, that's a big look. You could put Venus out where Jupiter was and it'd still be in the green. So yeah, pretty insane stuff there. How's Mars doing as well? I want to keep an eye on Mars, because obviously Mars is somewhere we're going to be visiting later on in this series, once the sun does get big and nasty enough to really support Mars. So yeah, Mars is just looking pretty dead still at the moment, unfortunately. Nothing really going on there. Okay. So pretty... Hey, what's that there? Hey, yeah, let's fix that. Let's replace it with a new Mars. Yeah, we can't be having that now. There we go. So fresh Mars spawned in. Okay, cool. That will also remove Mars off our list, unfortunately, but we'll just add it back. So, okay, Mars is down here now, unfortunately. Okay, so there you go. Okay, there is Mars. Looking good. All right. And then what I'll do is I'll give Mars its good old sort of redder trail as well, like I used to always like to have it. So there we go, Mars, and then Earth. Just so they stand out a bit, you know, got to have their distinctive colours, so that's better. Alright, cool. So, still in the solar system, nothing obviously in the outer solar system to report at this time. As, yes, it's just business as usual in the outer areas, really. I mean, yeah, we could say Saturn's rings have disappeared at this point, and maybe Triton has fallen into Neptune, but we're not going to dive into moon activities. We're just focusing merely on the sun and the planets here. Maybe we'll have, like, a colonized Titan or something, or throw Titan in further down the line. But yeah, for now we're focusing on the planets and the sun's evolution rather than any moon events and bits like that. So yeah, Saturn's rings would be gone at this point. Maybe Triton would have crashed into Neptune as well, and obviously Phobos, that probably would have gone into Mars at this point as well and created a ring system, because obviously it's if you didn't know, Phobos is slowly getting closer and closer to Mars as the years go by, and eventually it will be torn apart by tidal forces. So yeah, poor old Mars is not gonna, well, it's gonna lose one of its moons in the future. So there we go. But anyways, time to evolve. Let's go. High speed evolution here. Obviously, solar system's changing. Everything's still just in place. So solar system is nicely evolved to a point where its orbits are all nicely in place and intact. So looking, this will slow down time again. So we can see Earth's surface temperature almost going up to 60 degrees for some of that simulation there. So yeah, we're going to get pretty hot at Earth. Not looking good. Okay. Mars as well, obviously no interactions at Mars yet. But anyways, time again for the sun to slowly get a little older. So again, just slight... let's go to... Actually, I want to... For the sun, I'm going to go to just default colour scheme as well. So we'll slowly start to see its colour change as it does lose its temperature. So again, the sun's just getting a tiny bit larger. The luminosity, or the surface temperature, is going down, and obviously luminosity can go up to 1.4 suns now. So you can see the zone is getting bigger. It's almost reached out into the full asteroid belt. So for instance, Ceres is starting to receive that higher energy from the sun at this point. Okay, so anyways, it's evolve time. We can start to see it. Venus, especially Earth. They're the two we want to be looking at the moment. That's where the most activity is going on, is Venus and Earth. The two highest atmospheres in the inner solar system. That's where we're going to see the most greenhouse take place. You can see Earth. How you doing over here? So again, not looking too good. Maybe we're going to start seeing some loss of water due to evaporation. So that's a little too much Earth, but yeah, we want a bit of water still to show. We don't want it to be completely. That's too much water, Earth. Oi. Ah, it's just going to do that, is it? Where we just can't have the perfect amount. We just either have it or don't have it at all. That's a bit annoying, Earth. Why'd you have to do this to us? Oh, that's so frustrating, Earth. Why'd you have to do that? Oh, there we go. Yes. So something like that. So we can see water's still there, but we have lost a considerable amount due to, obviously, evaporation. So if we look at Earth now, no idea why ice is still there, because that is just... I mean, how high is the coldest? So it's still at minus 24, but yeah, Earth not looking too good now. So we did lose some of the water. More land showing up, obviously, and I think underneath we're going to start to see just less and less greenage as obviously plants will start to die and lose that sort of turns more effectively more desert-like. Obviously, if there's no grass, it's just going to be dirt. And just sand and gravel and all that. So yeah, no more plants. So you can see the greenery is slowly disappearing. Let's get rid of this. That's what our primary colour was. Yeah, so I think a darker green is in order there. So we're slowly just going to lose that greenery on Earth, unfortunately, and just more shades of dull, dead-looking colours that are going to appear. And this melts. Can we just melt that ice? I don't think that should be there really. I think the polar caps, or any remains of ice, will be very, very minimal at this point. So clouds, again, I think double thickness now, as we are going to see just higher evaporation levels, higher CO, especially CO2, going to be going up by the high limit. Maybe the atmosphere is going to start going a little more, just more cloudy, just more thick. There's maybe, yeah, something like that. just a tiny bit, so we can see Earth is not really. It's past its heyday, that's for sure. So not looking good. Humanity at this point, I think you better get out of there. Anyways, moving on. So let's continue. Alright, let's let it evolve. Get rid of the ice stuff because that shouldn't even be there at this point, and then that's not really useful either. So yeah, we'll just keep an eye on the water, vapor, surface temperature, and then obviously Mars at the bottom there. Actually, no, we don't really need that now. It's just, yeah, just have all the 4 planets. I think that's probably the best way to do it. Okay, so again, evolution. Let's keep it rolling. And then again, Sun. 1.5 luminosity. So again, the zone is going to get bigger and bigger. So we can see Earth is now in the red zone. So it's going to get very, very hot here. Not looking good for Earth. You can see that looks like the water may have dried up a bit more since I had a little play of it. So yeah, not looking good there. But obviously higher CO2. We're going to start to see Earth, and I think this is definitely a good idea. Is I think the infrared's definitely going to go up. So we're going to slowly just have that go up a tad to basically 100%. Higher infrared levels. So now you can see Earth is really increasing higher in temperature now. The infrared's gone up. Obviously, higher CO2, more gas in the atmosphere. The water evaporating as well. You know, it's not looking good. I think a lot of organisms at this point, Earth would not be the place for survival. So, yeah, that's bad. Maybe the water has a more murky sort of look to it as well, so maybe it really does lose its sort of colour at this point. So we look underneath now. Yeah, that doesn't look very friendly, does it? So it's all dying out effectively here. Yeah, so it's just a very sort of dark, murky, horrible sort of colour, I guess. Just nowhere near the nice blues it once would have had. So I think, yeah, that more murky look to it. So Earth is really not looking good, and I think maybe the atmosphere at this point is going to start just looking more hazy, just cloudy, horrible. You know, it's starting to get that Venus effect to it. The global greenhouse effect is probably starting to kick in now, and yeah, things aren't looking good. So, what colour do we want to go? Something a little more of a creamy yellows. Yeah, somewhere there, I'd say. So it's still not fully like yellow, toxic like Venus, but no, it's getting there. So if we just get a closer look at Earth to see now, yeah, that's not looking very friendly at all. And you can see, yeah, the water, obviously we're losing it. So I think that's probably a good representation of the old Earth there. Okay, and maybe cities. I don't know, would humans still be here? Who knows? We'll leave them on there for now. Anyways, the sun. And actually, Venus, how you doing over here? So, almost at 500 average at Venus now, so you can see that red area has spread. The coldest point of Venus, yeah, still pretty insane. Okay, let's continue. So, look at Earth's average now, 79 degrees. The coldest points, yeah, they're still in the minuses. That's not going to be last long, but the highest points on Earth, on our supercontinent area here, that's not looking good whatsoever. Okay. Mars, how are you doing? Any temperature at Mars yet? No, still cold at Mars, nothing going on there. Sun needs to be a lot more powerful for Mars to get any sort of levels. Okay, anyways, let's continue. So Sun going up. So that luminosity radius, just, you know, it's still getting bigger with the Sun. 1.31 luminosity going up again. 1.65. Again, we're going to save for simulation just in case of any issues. There we go, let's get that saved. Okay, Earth's average temperature, 87.2. Ooh. So, Venus, 600 plus now. Okay, so that's gone up 200 degrees since we started, pretty much. Because Venus normally sits around, I think it's 430, 440. Now we're in 620 almost in the highest points. So, yeah, Venus, not looking good at all there. How are we doing at Earth? So, yeah, 54 degrees. So, yeah, Earth is really, really not enjoying this now. So yeah, that's bad. Very, very bad. I think water levels are going to decrease even more. So 0.001, so you can see that's a big decrease in our water levels. You can see there's hardly anything left now of Earth. Now, that water's not looking good. And I think any sign of greenery would be completely sort of gone at this point. So You know, it's just going to be a barren, dirty desert, dead rock, effectively. Not much here. I guess a sandy sort of just scorched earth, effectively. So a desolate, sandy, covered in... Yeah, it's just going to be dirt, sand, and rock, isn't it? I mean, at this point, so it's just going to be a very baked planet. Not much going on here. It's all about just finding the right sort of look for it. Maybe... no, that's the primary colour. So I'm going to keep that as the desert, sort of sandy look to it. And then the other elevation... I mean, it's mostly the same elevation level, but yeah, you can see there's a few changes there. So we're going to have that completely darked out. Just scorched. Just... yeah, nothing left of what we would have once called home. And then water, I mean... I think it's probably more going to be more like that, you know, it's drying up. Not much to see at all, you know, not looking good. So what we once called home, city lights gone at this point, snow and ice, obviously none of that. Water, not looking good. And atmosphere, I think, is going to start to slowly creep up more like that. So then you get something like this, and that's not looking too nice now, is it? Ooh. So... you can see it's really getting the greenhouse effect now. You know, the greenhouse effect is kicking in hard. Clouds, again, more toxic-y looking. Opacity, atmosphere opacity, going to thicken up. Getting like Venus in that thick atmosphere. Lots of, obviously, CO2 levels here going to be a lot higher than Venus ever is. So once that greenhouse effect does kick in, Earth will be skyrocketing past Venus's temperature. Once the greenhouse effect really kicks in hard. So we'll have to manually do that. But yeah, Earth... the last drains of water here, that's all you're going to get now. So, I mean, you're not going to be surviving very well anywhere. So, looking good. And look at Venus, 513. Start to see some temperature. It's glowing hot. Why has Mars gone? What's happened to Mars? What's that all about? Oh, get rid of that water out of here. I shouldn't have any water or hydrogen. Get that. Yeah, that's better. What's that all about, Mars? This atmosphere is a little visible either. Oh, that's just because of it's thin. There we go. It's thickening out. Maybe Mars is having a dust storm at this point. Who knows? But yeah, we'll leave Mars alone. So Earth and Venus, they are looking like sisters, brother and sister planets. Now look, Venus is Earth's sister. Well, they do look really familiar and similar now. So yeah, Earth has got that greenhouse effect going on. They will make it actually look like Venus's sort of colour. So yes, I mean, really not as thick atmosphere as Venus though. Yet. So there we go, but I think that's Earth probably in its final sort of customization form. Not looking good there at all. I think it doesn't deserve the colour blue anymore, that's for sure. So there you go, something like that. So turn the zone off, that's your orbits. So Earth is now a yellow shade, Venus is still its orange. So yeah, not looking good. So at the moment, in this present time, no place is habitable in the solar system. So obviously Mars, temperature hasn't reached Mars yet. Mars is still cold. Nothing going on. Unless humans colonise it early, Mars, yeah, still too cold for any sort of activity. But anyways, Sun. Speed up time. Let's evolve. So there we go. So Earth, Venus, not looking good. I think, again, the Sun is going to slowly go up. And I think, actually, this is the point where Earth's atmosphere and the CO2 is really going to start going insane. So we're going to go down here. Albedo, and we're going to leave that alone. But it's down here, atmosphere layers. We're going to put it to 2, so that's a double. So, bam. So that's double trouble. That's going to get hot quick. So there you go. 85, really, really dramatic increase now. The sun, extra sun energy. Atmosphere's getting thicker, more greenhouse. Not looking good. There's a greenhouse effect, isn't there? Where's that? Albedo... oh, that's the greenhouse effect is there. So 90 degrees. How much warmer the body is because of its atmosphere? 90 degrees warmer because of the atmosphere currently. So really exotic. 126 on Earth now. So yeah, the last patches of water, in theory, they'd be on the north and south poles in reality, but obviously the game, it's a little harder to do that. So obviously the water will be just, yeah, it'll be underground, north or south poles probably at this point. So you can see, yeah, that's just looking very, very horrid. Hardly anything left at all. I mean, that's all just going to disappear naturally. I mean, I don't think I need to really do anything to make that dissolve. So, poor old Earth. Not looking good. Mercury. Surprisingly, not much activity at Mercury. It's gone up a little bit, but yeah, not much. So no atmosphere, no greenhouse. It's just relying on the sun for warmth. Venus, 606 degrees now. So that's getting pretty spicy there. So, Venus. It's going to be glowing hot. I'm guessing Venus's atmosphere will definitely thicken up as well. You know, really, really dangerous there. But again, no CO2 on Venus, so it's not going to have that skyrocket. It's already a global greenhouse at Venus, but Earth hasn't reached that point yet. It's getting there, but full-on global killing greenhouse. Need a little more temperature from the sun to really kick that into gear. So we're going to go straight to the sun. We're going to go straight up, a double luminosity here. So looking very, very bad. Radius, again, that's going to go up. 1.5 suns. Press the save. Get that in there as well. There we go. Venus, 786 degrees. Earth, 202 degrees. Highest temperature now. And again, I think at this point, Earth's atmosphere is going to really start to have problems now. So we're going to go all the way down here. We're going to go up to 4. So that's, or maybe 6. Even higher. Killer atmosphere is really kicking in. Global greenhouse effect. It's going to go absolutely wild now. No more water. Look, the water, there's a tiny bit left, but it's, ooh, look at that. It's nothing. It's just that tiny speck left there. But I don't think that's going to last long on Earth. 308 degrees at the highest. The coldest point is now 150. Water, you're getting removed manually. Water completely gone. All in the atmosphere. Gas and plasma, as you can see. So Earth is completely finished. Maybe that atmosphere is going to really foul looking, yeah, clouds. I guess we'll keep the white clouds just so it's visible, but just a slight yellow tint to them. But double thick coverage, opacity full on there. Earth, horrible place to be now. 233, and I think at this point we're going to see the global greenhouse kick in. So when I mean it. So if we look at Venus, for instance, as a comparison, Venus's atmosphere layer. How many atmosphere layers does Venus normally have? Is it 215? Is what Venus normally has, but Earth has got all of that CO2. So it's going to be a little higher than that. So Earth's global greenhouse is going to be a monster. So if we go down here, so Venus was 215. Well, we're going to go higher than that. Now the global greenhouse has kicked in. We're going to go to, I don't know, just a random, we're just going to pick a random value. I don't know, 337. So as soon as we press play, we're going to see the global greenhouse just click like a finger, and the temperature is going to skyrocket up. As we can see here, time is changing, but the greenhouse effect is gone absolutely berserk. Look at the Earth would have to be at the distance of Saturn, Uranus to really be any time. You see the temperature is now scorching hot. Earth not looking good. 500 plus. It is now going to overtake Venus as the hottest planet in the solar system, even though it has it's further from the sun. That greenhouse, that global greenhouse effect, is going to absolutely skyrocket the old Earth to the hottest planet. So even hotter than Venus now. So yeah, horrible, disgusting, just horrible place to be now. So there you go. Yeah, as soon as that global greenhouse kicks in, obviously Earth, like I said, it's got way more CO2 and all that water vapor in the atmosphere. You know, that's going to create way more effect than Venus has, because Venus doesn't have all that as much as Earth. Venus is a lot more natural, but obviously Earth has got all that. Remember, all of humanity's CO2 and stuff to begin with, but obviously just all more from just natural causes as well. So 1,000 degrees Earth. I mean, Venus is still at 700, so no, Venus is still getting up there as well. So yeah, Earth looking very, very bad, very, very hot now. So not looking good at all there. Anyways, again, the sun. And as we can see, Mars, 17 degrees at the hottest. So maybe Mars at this point will start to see some sort of change. So maybe there's still, see, look, the cold, it's still pretty cold there. So maybe the sun needs just a little more kick to it. So again, luminosity, 4. Just coming up to 4 luminosity of sun. Just a tad more. Radius, obviously, getting bigger. Temperature is cooling down dramatically, obviously, because the sun is getting older. Double the size of what it once was. But now, if we go to Mars, so it's warming up big time. Mars is. So maybe humanity at this point, maybe we're trying to start the colonization process of Mars. No, I'm not going to go insane, because look, it doesn't have the atmosphere to support the water. Any water you add to Mars, it loses. So Mars needs more atmosphere protection to really keep this going. So maybe humanity are trying, they can't figure it out yet, so Mars just isn't there yet. You know, it's still working on it. But maybe just maybe its atmosphere gets a little kick it needs by humans trying to start, or trying to use fossil fuels or whatever, or create stuff to boost the atmosphere. So maybe the surface pressure will get a little, just a little increase, you know, just a little bit, something like that. 0.1 ATM, just to hold on to that atmosphere. We're trying to boot start Mars to get it where we want it. So there we go. But Mars still just hasn't got the temperature to really hold on to any water yet. So it's still just not warm enough. But humans are starting to try, and maybe yeah, with humanity trying to start, maybe Mars is clouds. You know, we're trying to get some gases going, so maybe it's clouds start to sort of show up a bit. So humanity are trying hard. They're trying to get Mars to where we want it. So coverage and opacity. So we've still got fluffy clouds, nothing too insane yet. We're trying to kickstart Mars into a new era. Maybe it's obviously gets a little more fadey as well. We're trying to get something started on Mars, but we just haven't cracked it yet. So there's Mars. So there's our bit of fantasy. So obviously it's still a hit or miss question if Mars will ever be colonized. So we're just gonna have a bit of fantasy there and try and get Mars going. Obviously Earth at this point, global greenhouse effect, too much for Mars, or too much for Earth to handle. It's 1300 degrees. Mercury's almost at 400 now. So to put that in comparison, that's roughly what Venus is today. So even Mercury's getting into that real killer zone. But Mars, just further from the sun, that makes a big difference, and it's still just not warm enough for any sort of interaction yet. Now the zone. So if we look at the sun as well, now the zone is about to reach Jupiter. How's Jupiter's temperature? Jupiter, hello. Any changes? Minus 102 degrees. So still, yeah, nothing in the outer solar system that's really notable yet. We can take a peek at Ceres. See if Ceres has reached any point of temperature. Minus 40 degrees. Okay, so Ceres is getting a little bit of kick to it now, but obviously nothing too insane. So there we go. What does this do? Advanced time. Oh, okay. Oh, that's cool. I didn't know you could do that. I never knew that existed. Advanced time. So you could actually... I've never ever clicked this button. Oh, so you can actually change how much time evolves. Oh, that is cool. So I want to try, just for a bit of experimentation, because I've never tried this feature in this game. I don't even know how long this feature's been in here, this advanced time. What if I evolve it by 1 billion years? That's roughly where we're going to be sitting, so what if I do advanced time? On arrival, pause. So... Or what we'll do is just to make it easier, can I... Hey, I want to type in here, hey. Or if I... So if I put the date, can I... I just want to type. Years, million years. It won't let me type. I can type here though. So what if I go to the year... Okay, we'll go to 1,200,000,000. So 120. Then 1, 2, 3. 1, 2, 3. Enter. Can I start? Is that too much? Play. Oh, is it? We can't go to the year. Is it too much to it? I don't know how this feature works. Did I just delete something? Mars. Oh, no, everyone's still there. Okay. I don't know how this works. Advanced time. Oh, it just doesn't want me to evolve any... I don't get it. How does that work? So it doesn't let you type. Maximum speed off. See, I don't get how that... Oh, right. So what's it? So... Interesting. I'm still not sure how this works. We did just boost something, but I don't know really how this works. Whoa. I don't know what I'm pressing. This is weird. I'm just going to leave that alone. I have no idea what's going on there. Very, very bizarre. Yeah, I do not want to be touching any of that. I have no idea what I'm doing there. If anyone knows how that works, let me know, because I've never tried that. But anyways, onto the solar system. Enough of me fiddling around. Right. How are we doing at Mars now? Still just hasn't got the kick it needs yet. Okay, so the sun. Continue. Let's continue going. Lunar or radius getting bigger. It's losing temperature. Look, we're starting to go into a red giant sort of look. Now look how big the sun is. No, it's getting bigger. Luminosity. Going up to 4.5 suns. Mars, how are you doing? Ooh, maybe that's where Mars needs to be. So where's Mars sit? So 20. Oh, okay, so maybe this is the point. This is where Mars gets what it needs. Might still just not there, but maybe just a bit of humanity and a bit of interference with our powers of God will give Mars what it needs. So it still can't hold on to the water. Look, so maybe after a long period of time, humanity have finally figured that out. We're going to get it straight to roughly just under the atmosphere of Earth. So that should be enough to look after some water. I'd hope. I mean, we can hope. So Mars has got what it needs. Humanity have figured it out. It's still losing the waters. You know, Mars just can't hold on to it. Let me just go up to basically an Earth atmosphere. Infrared. Give a bit of infrared. Get that little Mars warmed up. Albedo. We'll leave that alone. But maybe Mars, yeah, it's just got what it needs. So it's starting to sort of figure it out. Almost there. Water will look a little different, so have a different shade. Something like that. Ooh. Yeah, I'd rather the water a slightly different colour, like, so obviously different planet. Maybe the water will look slightly different. Okay. Clouds, yep. I'll leave the clouds alone. City lights, yes. Then I think it's a little too much water. I think we need somewhere there. Try and figure that out. It still just can't hold on. Mars, why can't you hold on to it? Oh no, Mars just can't do it. But you know, we're trying. Humanity's trying. They're trying to get it to work with Mars. You know, it's a close one. Okay, so then Mars as well. For instance, just trying to get that photosynthesis, trying to get the green to sort of kick in there. So we've got something like this now, so they're just trying to get Mars going. It's still going to retain that desert look for the time being, though. That orangey, just creamy Mars look. Obviously, the volcanoes, they've got ice and snow on them now. But yeah, we've got a sort of a mix of the green and the Mars dust colour, just trying to fight away the dust and get some plant life going on Mars. So we kind of end up with this at the moment. So it's almost like vegetation. We're trying to get vegetation on here. So there it is. And then atmosphere, we're going to lower that down. So we're just trying to boot Mars into where it needs to be, but it's just struggling to hang on. So there we go. Okay, so Mars at this point, that's where your safest bet for life is. It's losing the water. It just can't hold on. Mars, look, it just can't do it. Oh no, Mars. Oh no, it just can't do it. You know, we can try everything. It's got the atmosphere it needs. I don't know why it's not working. You know, 1 ATM, that's where you should work, Mars. Just a little bit more. Maybe losing a little more temperature from the sun to hold. But obviously the sun's more vicious here. So, you know, it's a trouble. That Mars may just not be the place for home in the long term. So it's got the average temperature. Look, it's got the temperature it needs to get in there and get the look. That is roughly Earth at present day temperatures there. I mean the high, yeah, that the little higher. I mean, you see, it's still, yeah. You know, it just can't hold on to the water. Look how quick it loses its water. Look at that. Oh God. But you know, for this point in time, we'll just freeze it. That is how we want our Mars to be. It's a bit glitchy, Mars. Look, Mars just does not want to hold on to any water at all. So I think, I mean, it's probably the mass that's upsetting it, because I know, like, with this game, planets have to have a certain mass to really hold on to water correctly. So maybe Mars just isn't cutting it in this simulation. I don't know, but it's a bit annoying. But we'll just have to roll with it, unfortunately. But yeah, no, we got Mars where we wanted it and how we wanted it to look. So, you know, it could be worse. Why can't we change our atmosphere colours anymore? Where's they gone? Oi. Can change opacity settings, but can't see the actual colours. What's that all about? Bit weird. I can't even hide the atmosphere. What's going on here, Mars? Oi. Very bizarre. No idea where I can't see those. Maybe the atmosphere's been worn away? It has! Look! Atmosphere! Completely... What is that? Look, so add that back. So it looks like the sun was ripping the atmosphere off as well. Yeah, now we can see it. So for instance, to turn that off. That's where we're trying to get Mars, but obviously it just won't have it. Or maybe it will. Maybe the atmosphere was the problem. So, for instance, and it still loses. It just can't hold on, Mars. Look, it just won't do it. Atmosphere mass, double it up. Let's just see if we can get it to work. But I don't want to spend too much time on Mars because obviously, the more we evolve the sun, Mars won't be holding on anyway. So it's all just a matter of time, really. But you can see the water on Mars. As much as I want to increase it, it just won't have it. So we'll see Mars. We've seen Mars in its sort of life haven, but the sun is merciless, and Mars will not be forgiven or not be spared. Probably the correct term. The luminosity of the sun is going to be too much for Mars to sort of handle. So we get Mars colonized for a short period of time, but it's not going to be lifelike like Earth was for all of the millions of years Earth was. Or you know, maybe Mars will last for maybe 500 million years most, but obviously Earth's lasted a lot more than 500 million years. So yeah, the sun's evolution at this point is faster, so Mars will not be a safe haven for as long as Earth. So, unfortunately, we're going to see Mars lose all of that water, no matter what happens. So, if we watch here, the temperature of the sun is going to scorch Mars. We can see the water dries away. Mars is now back to its former self. And, unfortunately, any signs of plant life, so effectively, it's going to go back to that. It's just going to lose all of it. And, obviously, you know, it's just going to sort of go the way it was once before. Maybe a slightly more toxic looking atmosphere from any CO2 that was created on its short lifespan. But again, Mars will probably have the same fate. Nothing. It won't be like Earth with the crazy greenhouse or anything. But you know, it's still going to have that sort of thicker atmosphere to it, if the atmosphere even lasts effectively, because it's always going to be thinner than Earth or Venus. So there we are. So there is Mars. So I'm going to pause it there for today's episode, guys. So I hope you've enjoyed it so far, and that is just a sort of a more detailed look of evolving the solar system from the present to its death. So the sun has gone from, if we look here, it's gone from 1 radius to 4.27, and it's gone from 1 luminosity to 8.64. So 8 times more luminous than it is now, and look how much carnage it's already causing. Earth is out of the way, even Mars has now passed its point of life, so not looking good at Mars either. So yeah, look at our inner solar system in general. It's not in a good place. So if we come down here, the sun's obviously bigger. Ooh, a lot bigger. So we head down here. Oi. So all the way down here. Can I just head to Earth, please? Come on. Enter. Come on. Oi. There you go. So the inner solar system stands at this right now. So even Venus now scorching hot. You know, getting to that dangerous level. So Venus's atmosphere. Can't even see the thing now. Earth is the hottest. Then obviously Mars, Mercury. Again, Mercury. It's not looking good. 404 degrees at Mercury at this current point. So Venus 999 at its hottest. So pretty wild indeed. So there's our lineup. So now there's no place for life in the solar system. Mars has gone and been and gone. Nothing left. City lights. No. Get rid of those. There you go. So this is where the solar system sits now. We'll have a little view of Mercury, how you doing closest to the sun. So, yeah, that's pretty hot. So, look around. Sun's obviously a lot bigger than it once was. So, there you go. Save and replace again. There we are. But yeah, guys, I hope you've enjoyed this series to this point. And yeah, if you've got any feedback or how we can improve or any sort of events you think will happen in the next episode, let me know down below in the comments. Interested to hear what you think. And yeah, I hope you've enjoyed this more sort of detailed, slower look of the evolution of the solar system slowly as Earth and Mars have changed, because they've been the two highlights today. The planets with the water on, and obviously because Venus has been greenhouse for a long time now. Even at the present day, it's been greenhouse for a very long time. So yeah, Venus has just got hotter. Effectively, nothing really happened there. But obviously, Earth and Mars, that's where the big changes have happened. So yeah, I hope you enjoyed it. And yeah, let's see if we can go for 50 likes on today's video, guys. And also hit that like button. Yeah, hit that like button. This is going for 50. And also hit that subscribe button and help us on the journey to 27,000 subscribers. But yeah, that all said and done, guys. Really hope you've enjoyed it. And yeah, I will see you in the next video. Goodbye.